Welcome to this Royal Research tutorial. Today, we are going to build your first robot operating system, or ROS, package entirely from scratch. As you can see in this structural visualization, our end goal is to create a fully functional Catkin workspace containing a cleanly structured package with all required system dependencies properly installed. To follow along and complete this build, you need 4 tools ready to go: a Linux environment, a pre-existing ROS installation, an open terminal window, and your preferred code editor. Establishing this clean, modular workspace architecture right at the beginning ensures that your build tools can correctly locate your source code and libraries as your project increases in complexity. Step 1 is to create a dedicated directory on your local system that will house your entire ROS workspace. This terminal mockup displays the exact command you need. Type mkdir-p/home/Catkin workspace/source to generate the root workspace and its internal source directory. Once the directory exists, type cd/home/Catkin workspace- to navigate your terminal directly into that new workspace root. Now type catkin make and hit enter. Your terminal will immediately output a rapid scroll of text as the system generates the build and devel directories required for code compilation. Pay close attention to where you execute that command. A common failure point for beginners is trying to run initialization commands from inside the src folder. Always run catkin make directly from the workspace root. Executing this initialization command at the root level is the precise step that transforms a standard folder into a recognized, compilable ROS environment. Now that the workspace is active, we need to shift our location down one level. Type cd source to move into your source directory. From inside the source directory, we use the catkin create package command to generate the foundational shell of our new ROS package. In this terminal view, you can see the complete command. Type catkin create pkg, followed by your chosen package name, and then its initial dependencies. Breaking down that input string, myRobot serves as the designated identifier for your new package. The subsequent terms, ROS CPP and std messages, define the specific capabilities the package needs. They grant your code native C++ support and the ability to process standard ROS messages. By explicitly defining these required dependencies right now during the creation phase, you ensure the package links correctly to the broader ROS ecosystem and avoid complex compilation failures down the road. Open your new myRobot folder in a code editor or list its contents in the terminal to verify the internal file structure generated correctly. This folder tree diagram outlines the required architecture. You'll see the cmakelists.txt file, serving as the instructional blueprint for compilation. Moving down the list, you also have the package.xml file, which acts as the central ledger for metadata and dependency tracking. Finally, the diagram verifies the presence of the empty src and include folders, reserved for your future source code and header files, respectively. With the internal structure confirmed, we automate the installation of missing system dependencies using a dedicated command line tool called ROStep. Before running the tool, navigate back up to your workspace root directory by typing cd/tilde/catkinwest. This terminal window displays the exact syntax required. Type ROStep install -- from paths source -- ignore source -r -y. When you execute this, ROStep scans through your package.xml file, identifies exactly what components your operating system is missing, and automatically installs them for you. Using this automated tool regularly supports code portability. It allows other developers to identify and install the required components for your package using a single, standardized command. Your workspace is now cleanly compiled, and your new ROS package architecture is officially complete and structurally sound. Your immediate next step is to open that empty src folder and begin writing C++ or Python nodes that will calculate paths and control your robot's hardware. As you build out those nodes, remember to document your code thoroughly in your README file and prepare to use tools like ROS Launch to manage multiple active nodes simultaneously. This structured workspace provides the necessary environment to begin developing and testing your ROS applications. Thank you for building with Royal Research, and happy coding!